So we're talking scientific notation, and we're on page 14. And why do we use scientific notation in math and science, and really other subjects? Why do you think math and science, and at all? Do you know why? Yes, we make numbers easier not only to look at, but we're going to find out you actually can make your math easier to work with. So not only just looking at it, but working with it. Okay, so it's used specifically to write, and I put this informally, really big numbers and really small numbers. So there's a reason. Instead of writing it in standard form, the normal way we see it, and looking at all these zeros, why don't we write it in a way that's easier to look at? And then today, like I said, why don't we write it in a way that can make it easier to work with? And we'll see how that works later. Yes, ma'am?
Did you grade your...
Yeah, thank you for asking. I didn't get to your quizzes. I was trying to get them yesterday. I was here the whole day until back to school bash. Didn't happen. But I will have them for you Tuesday, because that's your next day back. So Tuesday you'll get them back. Thank you for asking. Sorry about that. I really wish I could have gotten it. Okay, the form. Oh, are you guys done?
Yes.
Okay. Form. We want to write it in this form, which hopefully you guys are familiar. A times 10 to the nth power. What? A and N stand for numbers, okay? So I'm giving you the format, and then you guys will be able to write the actual numbers. But A and N have to be special type of numbers. They can't just be anything. Does anyone remember what A has to be? What kind of number does A have to be? It's, yes, rational is an answer, but what else about A? It has to be specifically this.
A whole number?
Okay, it can be a whole number, but it can also be a decimal. So what else does it have to be? Okay, it can actually be positive or negative, which is a good point. We normally see positive. Anything else? These are good guesses. Okay, here's how I'm going to put it. I'll raise this up so you guys can see it back there. A has to be greater than or equal to 1. Like, Mr. A, did you just write that backwards? A has to be greater than or equal to 1. Now, if you're looking at this, which number is bigger, 1 or A? Looking at this notation. A, right? So A is greater than or equal to 1. That's how I'm going to write it. And it has to be less than 10. So this notation right here, I'll read it over and over again, is something you'll get more used to as Algebra 1 goes on. But here's how I read it. A is greater than or equal to 1 and less than 10. Do you see how A, therefore, has to be between 1 and 10? That's what I'm asking. That's what I'm putting up here, between 1 and 10. But what else could it also be? Not only between 1 and 10, but it can also be 1 itself. Okay? You guys okay with that? We'll go through examples of how that works. N is what type of number? Okay, positive or negative. That's good. Which deals with integers, really any kind of number beyond integer. But integers, does anyone remember what integers are? Integers, yes?
A number is off. A whole number is off.
A whole number or its opposite. So is 0 a whole number?
No. Yes.
Yes, 0, 1, 2, 3, 4, 5. What's the opposite of 0 though?
0.
0. It's its own opposite. Okay, this is the form. This is what the stipulations on A and N are. So they have to be this and that. Okay, let's go ahead and get some examples. Starting with numbers that are, I'm going to call these numbers that are really big, but I'll put up here numbers that are greater than 1. When I say really big numbers, I mean anything greater than 1. Like, Mr. You're saying 2 is really big. If for our purposes, like getting scientific notation down, yes, it's a big number. Okay, numbers that are greater than 1. Okay? Some people might say, Mr. A, that's not that big, but is it greater than 1? Is 396,000 greater than 1? Yes. So we're going to use this method that we're going to go through now to figure out how do we get this in scientific notation. Okay, this hopefully it's a lot of review, but it may not for some of you. Where's the decimal point right now? It's at the very end. It's right there. That's originally where it's at. There's only one spot I need to move it to in order for it to be proper scientific notation. And I'll tell you what I mean by proper. But does anyone know where to move it? Where to move it? Chelsea?
In between the 6 and 0.
Okay, so right here. Okay, if I move it 1, 2, 3, this number becomes 396, right? Is 396 between 1 and 10? No, so that can't be there. And you'll always use that pattern. Callie?
It'll go between the 3 and the 9.
So the 3 and the 9, so 1, 2, 3, 4, 5. Okay? Is 3.96 between 1 and 10? So that's the only place it goes. Oh, wait, Mr. A, can it go before the 3? Is 0.396 between 1 and 10? No, so you can't put it there. This is the only spot it fits. And then it has to look like this. What integer should n be? What's that exponent have to be? What do you think it should be? I know Callie knows. Sarah? To the 5th power? Wait, how'd you get 5?
Because you moved 5 spaces.
Yeah, the number of times I move that decimal point determines what my exponent is. So I moved it 5 times, positive 5. Wait, is it positive or negative? Man, I always get... Hold on. Hold on. Oh, yeah. Here's the way to figure it out. The original number, was it really big or really small? Really big. I know that exponent has to be positive. Must be positive. If you have a positive exponent in scientific notation, this number is big. What's my definition of big?
Greater than 1.
Yeah, this has to be greater than 1. Okay? You're saying 2 is big? What's greater than 1? 1.0000001? Yes, that one too.
What about 1.0000000?
Oh, wait, what? Huh? Yes, that is also true. Okay. Let me give you an example here for you guys to find. On page 15, look at the bottom where it says try these. You know I keep pointing out to try these. Okay, hopefully you're starting to get a pattern. It says try these. Write in scientific, number 1, write 751 billion in scientific notation. Oh, that's not that big. It's big because it's greater than 1. So let's define it that way. 751 billion. And I'll separate these because they're not the same problem. While you're writing that, some of these numbers, when I look at them, they're kind of random. Like, why'd they pick that number? So I actually Googled it. What is 751 billion? And it told me that's how many 751 cubic yards of gypsum estimated to be on the earth. You're like, what? Does anyone know what gypsum is?
A rock.
It's a stone or a rock. Yep, it's a natural stone that we get from sedimentary rock. Now, what's gypsum used for? Something very common. Plaster. You guys ever work or seen or heard of plaster? Okay, you think plaster is important? Yeah, it's used for building. It's used for art. It's used for many applications. Drywall, gypsum. Drywall important? Yeah. Only all of your houses have it. But yeah.
Fiberglass. Version of a gypsy.
Yeah, not gypsy, but gypsum. All right. That's how many cubic yards we have estimated to have on the earth. So a cubic yard would be if I had a box about this big, like a box this big and this wide. That's going to be 751 billion of those. So we do have a lot. Okay, which is cool because that number has meaning to me now. Okay, where's the decimal point right now in this problem? Yep.
It's at the end.
It's at the end. Cole, how many times should I move it? 11 times. Oh, man. Okay, I move it 3, 6, 9, 10, 11. It goes right here. So I got my 7.51 times 10 to the positive or negative? Somebody tell me why it's positive. Jack?
Because it's a big number.
Big number. And you're like, wait, but we can debate about big and small numbers all day long. Is it greater than 1?
Yes.
Positive exponent. So that's all we have to say. All right. Let's go with negative numbers. By the way, guess what's going to be different about, not negative numbers, excuse me. Guess what's going to be different about numbers smaller than 1 or less than 1? There's one big difference. It's going to have what kind of exponent? Negative. That's it. That's all you have to do. Okay. So here, numbers less than 1. So small numbers, we can call them. And we'll go with 0.0125, which is 125 ten-thousandths, which is a very small number. Wait, how do you know if it's small? Is it less than 1? Yes, it's small. Okay, so how would I change this one? Where does that decimal point, where is it? Well, thankfully it's written right here. But where should it go? You guys are making me. Is it Friday? Did we have lunch 2 periods ago?
It's Saturday.
On Saturdays, not this Saturday, but the next few Saturdays, I'm coaching my son's, Ezra's 3-year-old Y soccer team. Wow. It's fun. It was fun the last time. So they win? It's we didn't play a game, we practiced. So it's you guys, it's like half of your size. And watching these kids, some of them never played soccer before. Some of them never played with other people other than like their family or brothers or parents. And some of them have never done anything organized. Like they haven't done any kind of daycare or any kind of where they're organized. So it was fun, like all these different kids. And what's cool is when I'm talking to them, I get down to the level, I squat down, and then they're like all over the place. They're just like, and then one kid points up and there's a plane and everyone starts looking up. And my son's in there and I'm like, Ezra, and he doesn't hear me for some reason. And what I had to do is like a couple of drills. Like we ran around the half field, which is smaller than normal field, half field. We did don't break the egg, where you run around but you can't bump into each other because you don't want to do that a lot, especially as you get older. Unnecessarily, right? Because you could still do some of that. But for the young kids, and they're having a fun time, but after 30 minutes of practice,
30 minutes, wow.
I looked at my phone, I was like, oh my goodness, I'm so tired. And we went just 45 minutes total. I was like, that's tough. All that to say, I'm looking forward to Saturdays. Okay. They call me Coach because I don't think they even know. Okay, Elizabeth.
Don't you go backwards 2?
Okay, so you're going to move the decimal point twice. So the number is going to be 1.25 times 10 to the... Callie? Negative 2. Wait, I thought it was positive. Well, was the number big or small?
Small.
So it had to have a negative exponent in scientific form, scientific notation. That's it. You guys get that? Okay. Let's go through one last little review thing, and then we'll get into the new part. Guys, the new part. It can be if you're not paying attention. Yes. Like if you're told like phasing out, and then you go to the homework. What? That's going to be tough. Yeah. So hopefully not anyone in this room. All right, converting. So really we converted standard form to scientific, and now we're going to do converting scientific. So we're just going to go backwards, scientific to standard. Do you guys remember what standard form is? It's just how you normally see a number. The standard way of seeing a number. Okay. So let's start off with this number right here. 2.98 times 10 to the 5th. Okay. They already gave you it in scientific notation. You have to give it in standard form. Like how do you normally look at that number? Is this number big or small? How do you know it's big? Positive exponent. Automatically you know it's a big number. And big again, means greater than 1. Okay, so this is why I go through this, because a lot of people get it like, wait, should I go right or left? Wait, do you go small or big? Okay, don't confuse yourself. Which way should you go? Which way should you move that decimal point now?
This way.
To the right? Why? Not to the left. It should be, wait, left?
Left is negative, right is positive.
Yeah, man. Wait, say that again?
Left is negative, right is positive.
Okay, if you forget that right is negative, left is positive, which is easy to do, guys, if I move it 1, 2, 3, 4, 5 times, and remember to put those extra spots as zeros, is that going to be a big number or a small number? Big number. Is that okay?
Yeah.
Yes. So you need to make sure you get that. 298,000 is your number, which is a big number, and that falls with the exponent. Okay, let me give you one. Oh my. Page 15. Down with the try these, do number 3 real quick. Do number 3, write in standard form. I can give you something to wake up.
I'm good, Mr. Ray. But thank you.
Okay, once you get done, please check with your neighbors, see how you guys did. Hopefully you got the same answer, and hopefully that's right. Yes, ma'am? Yeah. Oh, okay, yeah, keep working, guys. Check.
With the decimal, would you count going like over the 1?
You would count. So here, this counts as 1. And then 2, 3, all the way to 9. So you're going to have 8 zeros. A lot of people think, should you add 9 zeros? Not necessarily. It just means how many spaces you move. Yes. Parker, what'd you get for number 3? Listen carefully, because I don't want him to repeat it. Because he's going to repeat it until everyone gets it. Go ahead.
I got 0.000000000.
How many zeros?
8.
8 zeros after the decimal. And then what? All right, decimal point. 8 zeros, 1, 3, 4. Any questions on that?
0.8 zeros, 1, 3, 4?
Yes.
No.
Point, and then 8 zeros, 1, 3, 4.
0 point.
Yeah, you can say 0 point and then 8 zeros. Okay. All right. Yes, ma'am.
Can you pronounce or say that correct?
Ooh, yes, I'll try. 134.
10 million.
10 billions.
Well, Mr. X. Well, you're smart.
No, 100 billions. Yeah, I missed a 0. 100 billions. Or millions. You know what I did with the gypsum? You know how I figured that out? I Googled it. I wanted to Google more. I just didn't have time. The other number, 0.0125, it's there are actually a few things that have that measurement, and one of them, this is not the one. I really wish I just remember what I put. I should have wrote it down. But it's like a third of the weight of your eye in pounds. So 125 ten-thousandths of a pound.
How much does the eye weigh?
The eye, it weighs 3 times that much. So 25, 20, 25, 37.5 ten-thousandths of a pound. Not very much. Few ounces, like not even an ounce.
You're saying the eye. Did you say?
Eye is light. Remember, 100, listen up. 125 ten-thousandths of a pound is if you took a pound, whatever that is, cut it up into 10,000, 125 of those would be a third of the weight. So that's not a lot. That's a good question. Okay, this is where we're going to end with operations here. Operations with scientific. Now, so far, really, if you've done scientific notation, you're like, Okay, it's just another way to write it. Yeah, I guess it's kind of easier, but other than that, it's not very useful. It's actually very useful because you can add and subtract numbers in scientific notation much easier than you can in standard form, which is a tough concept to believe. Okay, let me write this problem down and we'll work it out together. Oh my. 9.7 times 10 to the 5th plus 7.3 times 10 to the 5th minus 2 times 10 to the 5th. Oh my. Okay, let me do this for you here, guys. It's a trick question. What operation or operations are occurring in this problem? I have addition, subtraction, and multiplication. Okay, do you guys agree that's scientific notation, that's scientific notation, and that's scientific notation? Okay, if you can identify scientific notation, it makes this problem easier because this is what you would normally do. Normally you would do this. You would change that to standard form, standard form, standard form, then add and subtract, line up place values and all that. You're going to get a bunch of zeros in all these problems. That's not how we want to do it. Make it easier on your life. But why can you make it easier? Because of one of our favorite properties. The distributive property. Dun, dun, dun. Hold on. Swivel didn't even catch that. Hold on. The reason you can add and subtract these very easily in scientific notation is because of the distributive property. Dun, dun, dun. I'm going to pretend that was a cheer. Okay. I'm going to give you a couple of these, 4 of these problems, so please pay attention. So what I'm doing here is I realize I have addition and subtraction. All 3 of these scientific notation problems have a power of 10, right? 10 to the 5th, 10 to the 5th, 10 to the 5th. And what do you notice about all those powers? They are the same. Okay? That's a good thing for you. You do this. That's good. We like that because they're not always the same. And you could deal with that, but we're not doing that today. All right, so this is all I'm going to do. I'm going to take 9.7 plus 7.3 and subtract 2. I'm going to deal with the decimal parts on this problem. So go ahead and work that out. 9.7 plus 7.3 minus 2. Don't forget, adding and subtracting decimal points, what do you do with those? Adding and subtracting decimal numbers, what do you do with those? Line up, place value, decimal. Yeah, let's talk about that. How many of you got 15? 15 even? Okay, you can say 15.0, but 15 is good. Okay, I got 15 with those decimal parts. And then, because they were all the same base with all the same exponents, 5, 5, and 5, you just write it 15 times 10 to the 5th. You just keep the same base. Keep the same base.
I did it wrong, but it's the same answer.
Well, it depends on what you mean by wrong. Maybe it was different.
I put it in standard form, then I add them together.
Okay, you could do that, but that's much longer than it, right? Yeah. You can't. It's not wrong. It's just a longer way. All right, but I'm not circling this because it's not proper.
1,500,000.
Okay, listen carefully. It looks really close to scientific notation, but it's not. All right. Is 15 between 1 and 10?
No.
No, so I have to convert it to a number. Where's the decimal point? I got to move it here. So how many times? Once. So I get 1.5 times 10. I thought it was to the 4th.
You don't mess up.
Which one? Here's what I'm trying to do, Bella. You said to the 6th, right?
Yeah.
You are correct. But I need you to be confident about it. Somebody tell me why it's to the 6th and not to the 4th. Because this group is going to say 4 or 6. It's one or the other, and one of them's wrong. But why is it 6? You got to help me out. Cole?
You're adding one more decimal spot to the positive.
It's positive.
No, it's not because it's positive. I understand. It's not because this could be negative and it still happens that way. Callie?
It's because you had to multiply 15 times 10 to the first power, and you add the first to the fifth power.
Oh. Okay, how about this? That's good, Callie. That is true. Was 15 a number greater than 1 or less than 1? Greater than 1, right? So when I moved it over, it went up 1, right? Doesn't it make it a positive exponent? Not down 1. So to the, sixth is your answer. Okay, don't worry, you'll get...
You don't put it in standard form?
No, I don't want this in standard form. And sometimes it will say scientific, sometimes standard. This one's scientific. Oh my. Oh my. Guys, this is adding or subtracting. Sorry, I just like doing that. I'm so sorry. Yes, sir.
Did you get 1.5 to 6
Do you get how I got here?
Oh, because you make it in between 1 and 10.
There you go, nailed it. Okay, let's finish up, guys. 2 more problems, and I want to see if you guys can distinguish. This time we're going to multiply. What were we doing the last time? Adding or subtracting, or adding and subtracting. This time we're going to multiply. This one is 6.1 times 10. So I'm getting a little bit distracted over there, but I do have remedies for that. 2.3 times 10 to the 4th. Okay. There are 2 numbers in scientific notation, here and here. What's going on between them? Multiplication. Do you think we're going to do exactly like addition, subtraction? No. We're going to make it a little bit different because it's a different operation, but a lot of similarities. Here's the similarity. Okay. Oh, man. 6.1 and 10 to the 7th. What's going on between those two? What's going on between 2.3 and 10 to the 4th? What's going on between this number and this number? Does it matter the order? No, so I'm going to do it this way. 6.1 times 2.3 first, then 10 to the 7th.
May I have your attention, please, for any 8th grade students that applied for student council. If you would stop by Mrs. Thomas's classroom before you go to 7th period, please. Thank you.
My heart's beating. I hope the results are fair, and it is the Lord's will, whatever happens, but that's hard for 4 of you, or 4 altogether. Okay, but anyway, are you guys okay with me or the book switching from an X for multiplication to a dot for multiplication? Yeah, you should be comfortable. It's still multiplication. All right, so here, what's 6.1 times 2.3?
14.3.
I messed that up.
Yeah,
14.03. Now, this next part. Yes, ma'am?
Well, I have a theory.
Oh, theory, go ahead. Not a postulate?
Do you just add the 7 and 4?
Why?
I don't know. I'm just thinking.
But that's the question, not a theory.
Okay, guys, this is what I want to do. I want you to rewind, not to yesterday, but the day before. Did we deal with integer exponents before?
Yes.
Are these two being multiplied?
Yes.
Do they have the same base?
Yes.
What do you do with those exponents? Add them. You are correct. Your theory has been verified. But I'm marking that wrong if you gave it to me that way.
Oh.
Greater than 10.
Yes, greater than 10. You can't give me that.
So it's 10 to the 12th power, because I looked at my book.
Okay, yes.
And it's trying to...
Yeah, this number right here, 14.03, I got to move it, right? I got to move it back 1. And this number was bigger than 1, so this goes up. Up 1, because I moved it once, goes up once. If I move it 3 times, how many times do I move it up? 3. Yeah. Sorry, not a trick question on that one. Okay, this is my answer, final answer for that scientific notation. And last problem, and then I'll let you go. number, or not number, but division. So divide. Oh, oops. Let's end on this note. Dividing 4.731 times 10 to the 8th over 5.7 times 10 to the 3rd. I think it's just third, yeah. You could do negative third, but you can, on this one we're not going to do it. Okay. Last time with multiplication, didn't we multiply the two decimals? And then we multiply the two powers? That's multiplying. What do you think we do with division? Divide the two decimals, divide the two powers of 10. That's all you do. So here you're going to do 4.731 divided by 5.7. 4.3.
5.
Sorry, I'm losing what I'm saying. 4.731 and 5.7. Yeah, that's what I should have. Can you do it? No, you got to move it over once here, once there. So 57 goes into 47, no times. 57 goes into 473.
5.
Okay, so I heard two numbers.
6 times.
I heard another.
4 times.
7.
7 times. 8 times.
8 times. Now, listen up, guys. We know that because we have the answer. Well, some of you can see where it's at. But the way I know it is really this. I take an estimate. I'm like, okay, 5 times. You work that out and you're like, no, that's too small. But 57 times 8, 56, 45. You get 456. That looks like it's the number. You just try. And you get your 8. 456. You subtract. 57 goes into 171.
No, 3 times.
Exactly 3 times. And thankfully we'll do that for you on your homework. You're not going to have repeating or non-terminating decimals.
Then you subtract 3 from the 8.
So I got 0.83 times 10 to the, what do I do with these two?
Subtract.
Subtract the exponents. Yay! Oh, 8 minus 3 is 5. Yay!
It's in between. How do you make math so energetic? Oh yeah, it is.
That's a good question. Well, I had spinach in my sandwich. I had an apple. That usually boosts. No, I really enjoy it. Some of you are. Let me give you a little feedback here from the teacher. It's Friday. Like I can feel it's. The air feels like it's Friday. The faces look like it's Friday. But some of you are kind of proving that wrong. Some of you are actually just looking like it's a Tuesday or a Wednesday.
I like Tuesday.
And some of you are like, you hardly have life in you. I'm trying to get this life in you. All right, someone give me the final answer and why. Josh?
Is it 8.3 times 10?
8.3 times 10 to the 4th. Listen up, because this is the last part, and this is going to affect you. You notice our exponent went down 1? Well, you're like, well, we just moved it once, but was this number big or small to start with? Small. So it goes down 1. 8.3 times 10 to the 4th.
Well, homework is nothing. This is Friday. Please.
No. But I did do this to the...
Favorite teacher.
That means that you're already not.
Okay, sorry. I love you guys, but I'm not trying to gain your best friendship. I'm trying to gain your teachership. Yeah, best teachership or your best friendship. But I do care about you guys enough to give you some practice. I did minimize it a little bit. So this is what it is now. It's going to be numbers 11 through 15 odd. Number 18, and then 27 to 31 odd. So I minimized that dramatically, all right? So if you're like, Mr. A, that doesn't seem like you did. Well, I can assign you the regular assignment, and you'll...
Go to page 13. When you put add 30 pages,
I may do that.
Here you go, Chelsea. Yeah.
Goodbye, Swivel.